Hello, everybody, and welcome back to the channel. I am beyond ecstatic to present my new Docker and Kubernetes course on Udemy. I've spent a ton of time making this the absolute best resource to learn Docker and Kubernetes from a complete beginner, and eventually this will take you to an expert with great knowledge and depth. I have so many diagrams that explain the concepts, and we're going to work through so many projects that you can have on your portfolio. And to prove to you that this is such an excellent resource, I've actually hosted the first 5 sections of my course on YouTube in this video. So the intro, what is Docker, Docker files, containers, and images, this optional challenge, as well as deploying our application. These 5 sections are going to be right here in this video. You can go ahead and watch it and judge for yourself if you want to continue and learn more. There's so many other concepts like, deploying a multi-container application, deploying it to AWS with ECS. We've also spent quite a bit of time learning the best ways to build a CI/CD pipeline. We also learn about Kubernetes, all of the different Kubernetes objects, and then we also deploy this to AWS, and we also build a pipeline. And don't mind the price of this course. At the absolute maximum, this is always going to be $10.99. I'll have a coupon in the description. And if the coupon is ever out of date, please bug me and I will go ahead and update it. But you'll never have to pay something like this for this course. It'll more be like $10.99. So go ahead and check it out and watch this video. Hello and welcome to my future Docker and Kubernetes experts. Thank you for taking this course. I've spent quite a bit of time making it one of the more comprehensive and easy to learn courses out there. And I am sure by the end of this course, you are going to be extremely comfortable with both Docker and Kubernetes. Now let's quickly talk about exactly what we are going to be learning throughout this course. We are going to be learning a lot. Let me just go ahead and show you some of the things that we're going to learn. Now, of course, if you are a beginner to Docker and Kubernetes, please do not get overwhelmed. We are going to cover each topic in great detail. So the first thing that we are going to cover is Docker. We're going to explain exactly what it is and why do we even care about it. After we learn about Docker, we can then move on to a very important concept called images. We're going to learn all about images, and we're actually going to build one on our local machine. Now, once we know all about images, we can leverage that knowledge to learn about containers and run containerized applications on our machine as well. Now, once we have learned all three, we can start learning some more advanced concepts, like building multi-container application and figuring out how to network between them. Another very important thing is persisting data, which could be an issue with Docker applications. We're going to learn exactly how we can persist data inside of a database. The next thing that we're going to learn is an easier tool that we can utilize in order to create multi-container applications. And now once we're done with that, we're not going to, have our application just in our local machine. We are going to learn exactly how to deploy our application to the most popular cloud provider, AWS. We're going to be using a service called ECS. Now, of course, that is not enough. We're also going to learn how to build a CI/CD pipeline so that we don't have to do this stuff every single time we make a change to our image. So we're going to learn quite a bit. Now, after we've learned all that, we're going to move on to Kubernetes. We're going to understand exactly what Kubernetes is, what are the benefits of Kubernetes, and what exactly is a Kubernetes cluster. We're going to learn about all of the different Kubernetes objects that are out there. There's so many out there, and we're going to learn about a ton of them. And then we are going to utilize Kubernetes to containerize a relatively complex microservice application. And then afterwards, we're going to get that microservice application, and we're also going to deploy it to AWS EKS, a different service. And then we're also going to build a CD pipeline. So this course is down packed. It has a lot of different components to it, and I made sure that every single section is explained in great detail with a tremendous amount of diagrams and practical examples. So I'm super excited for you to take it, and I hope you enjoy. So let's actually go ahead and start talking about some of the requirements that you need for this course. Now, luckily, there isn't a lot, especially not knowledge-based requirements. You need absolutely no Docker or Kubernetes experience whatsoever. However, it is nice if you have just the basics of a programming language, because at the end of the day, we're going to be utilizing some sort of code to containerize our applications with Docker and Kubernetes. So just the basics. Now, in terms of tools, well, let's talk about that. So the first tool that you're going to need is some sort of text editor. By far, the most popular text editor is Visual Studio Code. So I highly suggest go to Google, search for Visual Studio Code, and download this text editor on your machine if you don't have it already. Now, you are free to use any other text editor, but I am going to be using Visual Studio Code. So if you want to follow along verbatim, then, well, utilize this text editor as well. Now, when we actually go ahead and start moving on to deploying our application to the web, well, we are going to utilize AWS. And we're utilizing AWS because it is the by far most popular cloud provider out there. So I want you to learn how to, well, deploy an application with something that is really popular in the industry. So in order to create an AWS account, all you have to do is go to aws.amazon.com and just go ahead and try to sign in to the console. It's going to go ahead and prompt you to, well, create an account or sign in if you already have one. Now, one thing that is important to note is that AWS is not going to be free. It is going to go ahead and ask you for some credit card information. However, if this is your first year of utilizing AWS, there are free options in the free tier. Now, nonetheless, this isn't going to cost you a lot of money because what we're going to do is spin up our application and then tear it down as soon as we're done. You might incur maybe a few cents in charges if you want to follow along. Another thing that we're going to do is we utilize Docker Hub. Now, this isn't necessary except for one section. If you want to follow along as well, you're going to have to create a Docker Hub account. This is just a place where we can store different images that we'll talk about a little bit later. So go ahead, create a Docker Hub account. I believe this is free. You don't have to put in any credentials. Now, the last thing that you need is Node installed on your machine. So we're going to be using containers to run our applications most of the time. However, we are going to run some applications locally, so it is going to be nice if you have Node installed on your machine. So just go to nodejs.org and just download this right over here, the version that is recommended for most users. For all of this course, what we're going to be utilizing is Docker Desktop to run both Docker containers as well as a Kubernetes cluster. Now, luckily, the download for Docker Desktop is actually really easy. Just go to Google, search for Docker download, and the first thing that should pop up is Docker Desktop. So we're going to go ahead and click on Docker Desktop, and then over here is going to detect your operating system. For me, it is going to be a Mac. So what I'm going to do is I'm going to click on Mac for Intel chip. Of course, if you have the Apple chip, just go ahead and download this one. Now, this is just such an extremely easy process that I'm not going to go through it because I actually already have Docker installed on my machine. So go ahead, go through it, just follow the wizard, and later on what you should get is, well, this desktop application. So it's going to ask you to drag this Docker desktop application to your window as I did. You can actually go ahead and open it and you can see all of my running containers and images. And this is actually all it is that you need in order to run Docker as well as Kubernetes on your machine. And to check that everything is working a-okay, what you can do is do a few tests. You can open up your terminal. Let me go here, and you can just do docker-v to see the version of Docker you have installed. Well, you can see here, well, I got version 20. That means I have it installed. If you get an error saying that Docker is an unknown command, that means you haven't really installed it correctly. Another thing that you can do is check that Kubernetes was installed by checking the kubectl version. And as you can see here, we're not getting an error saying, hey, kubectl is an unknown command. We're just saying, well, what is this -v? Maybe I would have to do it like this. Or you know what, let's just do kubectl, and you can see we have a bunch of commands that we can utilize. That means kubectl and Kubernetes is working on our machine. Now, Kubernetes right away is probably not going to work for you, so that's actually okay. Later on, when we get to the Kubernetes section, we'll go ahead and configure our Docker desktop to do that. So if you are on Mac or Linux, this is going to be a relatively easy process. If you're on Linux, you can just click over here and go ahead and install it. If you're on Windows, this is going to be just a little bit more complicated. So what I'm going to do is for Windows, I'm going to go ahead and show you a list of instructions and some resources that you can utilize in order to download Docker Desktop on your machine. Unfortunately, I can't go ahead and do it with you because I do not have a Windows machine. But nonetheless, I think these instructions are good, and the process is, even though it is more complicated, is still relatively straightforward. Docker, especially if you are a beginner, is a relatively hard thing to grasp and understand. So instead of telling you what Docker is and exactly what it is used for right away, I'm going to give you a real life analogy that simulates what Docker is doing in the real software development world. And then, of course, I'm going to relate that to what Docker is doing, and hopefully that gives you a better grasp and understanding of Docker. So let's begin. This is you, and you are a businessman, and you thought of a terrific business idea that is going to make you a lot of money. So your aunt, she makes the absolute best rice and shrimp. And people love this meal. They die for it, and they're willing to pay for it. So what you decide to do is to turn this into a business, of course. So you go ahead and you hire the top chefs and you teach them this recipe. So these chefs now know how to make this wonderful meal, and now you want to go ahead and serve it to the world. However, the issue with this meal is very delicate, and it should be served and then eaten right away. So you can't really have a catering business or a restaurant. So what you decide to do instead is, hey, these chefs are going to be on call. Whenever you want this meal, just call us and we're going to send one of those chefs to your house to cook this meal up for you. So it would look something like this. So you have many homes. Let's say this house over here, the household, it wants this meal. So it's going to go ahead and call us. We're going to go ahead and send this chef. It's going to cook the meal for you, and then you can go ahead and enjoy it. Now this seemed great, but very early on, you noticed a very big problem with this business idea. What is it? Well, this meal requires a set of equipment to prepare. So these are the equipments it needs. So it needs a rice cooker, and it needs a special brand of a rice cooker. It can't be just any rice cooker. It needs a special blender. It needs these measuring spoons over here, as well as a pot and pan and an oven. So the first house that you go to, well, you go to their kitchen and they actually have all these things. How great is that? They have the rice cooker and it's the correct brand. They have the blender, correct brand. They have the pot and pan, exact same measurements. And they have also the measuring spoons right over here, as well as the oven. So you're able to cook the meal and the customers are extremely happy. However, another house goes ahead and calls us, and you go into their kitchen, and it seems as though everything is great, but they're missing the blender. Now, without the blender, you're not able to cook this meal. So in this house, in this kitchen, you're not able to complete the task at hand because you don't have the equipment needed. This environment doesn't provide you with the equipment needed to complete this task. Now, this is kind of a blocker. However, it could even get worse. Maybe a person that lives in a hut wants this meal, so you send a chef to them, and you realize they don't even have a kitchen. Like, that's terrible. They don't even have electricity to make it worse. So the bare minimum things that you need to create this meal, you can't do it, especially in this environment over here. Now, another environment, let's say this person has a really rich house, and of course he has all of the equipment, but the rice cooker is a different version. Maybe it is a newer version. And this meal, it can only be prepared with the older version of the rice cooker. So right there, the environment is dictating whether we can create this meal or not, whether we can complete this task or not. So what do you decide to do? You're like, you know what? This really sucks. The environment is dictating whether we can create the meal or not. So what I'm going to do is I am going to create the environment myself. So you create this food truck over here, and then inside of this food truck, you have all of the equipment needed to create this wonderful dish right here. So you have created the environment. So now, whenever there is a call, so let's say there's a call right over here for this, you actually do not enter their kitchen and create it. You just send the food truck there. You go ahead and you create the food for them, and then you just give it to them. And we know for a fact that this food truck is going to have all the equipment that we need to create this meal. So now, regardless if this house calls, we can just send the food truck and create the meal. Regardless if this hut calls with no electricity and no kitchen. Well, doesn't really matter because everything we need is inside of this environment right here. And we're going to go ahead and prepare the meal and give it to them. Now, if there are multiple homes that call and want this meal, we can just send multiple food trucks to them and cook them the meal. Now, you might be wondering, why in the world do I care about this terrible business idea? Well, what we did here is extremely similar to what Docker is going to do for our software applications. Let me go ahead and explain in the next video. In the last video, we went through a real-life scenario, but you're probably thinking, what in the world does this have to do with Docker? Well, watch this video, and I hope after this video you have a real good grasp of what Docker is. So let's say that you have decided to code up a project. So right here, this is your code. And whenever you want to run your code, you're able to run the command npm run start. So let's say this is a node project, and you're able to successfully run it on your local machine. Now, you're so proud of this code that you want to show this code to your teammates, and you want them to run it on their local machines. So what you do is you give them the code and you tell them, hey, run npm run start. And that is exactly what your teammates do. However, they are not able to run it on their local machine. So as you can see here, teammate 1, teammate 2, they run npm run start, and they are not able to start up your code base. Well, this is very bad. This is relatively strange. And to make matters worse, you decide to deploy your code on, let's say, an AWS EC2 instance, and also it doesn't run correctly on this environment over here. So what is going on? Well, your code requires a set of dependencies. So in order to run it, you need to have Node, specifically Node version 16. You need to be running on a Linux device, and it uses a Postgres database. So it tries to connect to a Postgres DB, and if you don't have a Postgres DB, it's just not going to be able to form that connection. Now, right away, you can probably see what went wrong over here based on the analogy that I gave you in the last video. So over here, your environment is kind of like this perfect house. It has Postgres, it has Node version 16, it has Linux. So you're able to successfully run your program. Everything is great. However, Teammate 1's environment is a little bit different. Maybe they have Postgres, they have Node 16, but they're running on a Windows device, not a Linux device. So they're not able to run the program. Teammate number 2 running Postgres, they have Linux, they also have Node. However, this is Node version 14, not Node version 16. We can tell Teammate 2, hey, upgrade to version 16, but maybe they're using Node version 14 to run another project, and if they have to go ahead and increase it to version 16, then that project is going to fail. So you can see here, also not ideal. And maybe in the EC2 instance that is in AWS, it just has Linux. It doesn't have Node, it doesn't have Postgres. So you can see all of these environments are different and they have different dependencies. So what can we do here? Well, there's two options. We can configure everyone's environment correctly. So we can say, okay, we're going to install Node 16. We're going to get Postgres. We're going to have Linux. Over here, we're going to just go ahead and upgrade this and bite the bullet. And then over here, we're going to somehow give you a Mac or a Linux machine and you're going to run it on that. So that is option number one. Obviously, option number one is terrible. We could have multiple different environments, hundreds of different environments, and if we have to configure each one manually, that is going to take us a long time and it is going to be very error prone. So, what's option number two? Well, run the apps in isolation with all of its dependencies. So this is analogous to that food truck. Instead of going into the home, we have all of the equipment inside of the food truck and it is in complete isolation of the home and we're able to perform the task. And same thing over here. What we want to do is just run our application, this application right here, in complete isolation with all of the dependencies. So this right here is the ideal solution. And that right there is what Docker is all about. Now this is a Docker logo, so we have Docker here, and right above it, you can see a bunch of square boxes. These are containers, and these are a very important concept, and if it doesn't make sense to you, do not worry. But containers are where we run our application in complete isolation. So now that we know that, let's go ahead and look at the Google definition of Docker. Docker is an open source containerization platform. So remember, containers are the food trucks. They're the things that allow us to run our app in isolation. It enables developers to package applications into containers, standardized executable components, combining application source code with the operating system libraries and dependencies required to run that in any environment. So that, in essence, is what Docker is. And hopefully, this long explanation will make it easier to understand this definition. So imagine if I just went ahead and just told you this is exactly what Docker is. I'm sure many of you guys would get confused. But after all that, I hope after reading this, this makes sense. So let's go back to our example. Now that we use Docker, what we can do is, regardless of the environment, whether it's an EC2 instance or it's our teammate's machine, teammate 1 machine, teammates 2 machine, we can run the application in a container completely separate from the environment. And in that container, we have our code, we also have Linux, we also have Node. And again, we have that in every single one. And well, we also need Postgres, so we can also run Postgres on a completely separate container and just connect the two. That way, we're able to successfully run our application in any environment. Now, this is the biggest benefit of Docker, and it really simplifies a lot of things like deployment, testing, DevOps, Ops, etc. But there's a lot more benefits that we are going to look at throughout the course. So stay tuned. In order to start working with Docker, we first need an application that we want to run with Docker. So that is what we are going to be building in this video. We're going to be building a very simple application that we can then run inside of a Docker container. Now, that application is going to be built with Node. You do not need to know any Node in order to take this crash course. That is okay. You can just go ahead and follow along. You don't even need to install Node on your local machine because remember, we're going to be running this application in complete isolation from your local machine in a container. So let's just go ahead and bear with me. Let's go ahead and build this project. So I went and opened up VS Code. Let me zoom in here. And inside of here, what I'm going to do is I am going to create an index.js file. And this is where our application is going to live. Now over here, I'm also going to create a package.json. This is going to contain information about the Node application that we have built, as well as any dependencies that we need. So let's go ahead and build out this app. So the first thing is in the package.json, we need to create, some configuration. So over here, I'm going to have these curly braces, and this is going to be in JSON syntax, if you're familiar with JSON, as you can see by the extension. And over here, the first thing that we're going to do is we're going to give our app a name. Now over here, I'm going to call this something like Node app. You can call it whatever it is that you want. We're then going to give it a version. So let's go here. Let's say version. We're going to give it a version of 1.0.0. And then what we're going to do is we're going to go ahead and give it an empty description for now. Description, we're just going to leave that empty. And then over here, we're going to specify the main file by saying main. And then over here, we're going to say index.js. And then what we're going to do is we're going to specify some dependencies that we need. So in order to run this application, what I want to do is I want to get some JavaScript dependencies that somebody else has created. And these are hosted in NPM. So over here, I'm going to say dependencies, and this is going to be an object. And I just want to get one dependency, and this is going to be called Express. So let me just quickly go ahead and show you what Express is. So Express.js, if I were to go here, you can see Express.js, if I were to zoom in here, is a fast, unopinionated, minimalist web framework for Node. So it allows us to build REST APIs as well as web applications with Node. Now this is going to be hosted in a package manager called NPM, right over here. So as you can see, it's hosted in NPM. It has 25 million downloads every week, so it's extremely popular. And in order to install it into your local machine, you can just do npm install or just add it into the dependencies. So over here, I'm going to say that, and I'm going to say version of 4.18.1. That is what I am going to use. I highly suggest that you use the exact same version as I do. So over here, we have defined our Node application, and we have also defined all the dependencies that we need. So let's go ahead into our index.js file and start building the app. So the first thing that we're going to do is we're going to go ahead and grab Express from that dependency that we just installed. So I'm going to say I'm going to require in Express. I'm going to create an Express application. And then over here, what I'm going to do is I'm going to say app.get. And then I'm going to say at this endpoint right over here, so the slash endpoint, I want to run this function. So this function is going to take in two parameters, the request as well as the response. So over here, I'm going to say response.send. I'm going to say hello world, like so. And then this is just going to specify the endpoint. So whatever endpoint I go to, let's say it's going to be localhost 3000, it's going to go ahead and send me hello world. But now what we need to do is we need to actually listen and instantiate this app. So I'm going to say app.listen. I want you to listen on port 3000. And then over here, I am going to go ahead and just do a console.log. I'm going to say now running on port 3000. Now, one nice thing is that you don't just instantiate the port like this. Maybe you can have a variable, say const port. You can say 3000. And then over here, you can just use the port. Then over here, you can just do something like this. Okay, so that is it. That is all we need in order to create this application. Now, what I want to do is run this application. So let's actually talk about how we can run this application inside of my local machine without using Docker in the next video. In the last video, we created this Express Node application, but now what we want to do is, well, to run it. So without using Docker, how can we run this application in our local machine? Now, this is something that you do not have to follow along with because it will require you to install some stuff on your local machine. And if you do not want to do that, that is A-okay, because later on, of course, we're going to be running this application with Docker. So there are two things that we need to do on our local machine in order to run this application. So the first thing that we need to do is to have Node installed on our machine. Because we are running a Node application, we need to have Node installed. Now the installation is relatively easy. You can just go over here, just say Node download, and you can see that you can just go ahead and click on whatever operating system you're using and download Node. But if you do not have Node installed, you're not able to run this application, which again is not ideal. So I already have Node installed, which is pretty good. So I meet this requirement. So if I open up my terminal and I say something like Node version or -v, you can see the version of Node that I have on my local machine. So that is A-okay. Now the next thing that we need to do is we need to install all of the dependencies. Now just because we have stated that we want Express, it doesn't mean that we have Express inside of our application. We need to install it into our app. So that is the other thing that we need to do. Now with the installation of Node, you also get NPM, which is a package manager for Node. So what I would need to do is do npm install to install all of the dependencies. And you can see here we get this node modules, and we also get this package.lock.json. The node modules is a directory that contains the dependency that you installed. Now you can see here, well, I only installed Express. Why in the world am I getting all these other dependencies? Well, that's because Express relies on other dependencies. So you're going to need to install, if you install Express, you also need to install all of the other dependencies that Express needs. So such as cookie, etc. But right here, this is the file that is going to contain all the code for our Express application. Okay, so that is all it is that we need. So now what I can do is I can start running this index.js file. So inside of my terminal, let me just zoom in here. I can run node index.js in order to run my application locally. Now it says here not running on port 3000. That's because if I have a typo here, should be now running on port 3000. But now if I go to localhost 3000, let's go here and I zoom in, you can see that I am running my application. So this is great. Now, one thing that I want to do is instead of running node index, what I can actually do is I can go to my package.json, and then inside of my package.json, I can specify any scripts that I want to run. So over here, I can say scripts, and then here I'm going to say start for starting my application. I'm going to say node index like so. So now anytime that I run npm run start, which is this script here, it's going to run index node. So now you can see here now running on port 3000, and we still get our app running. So remember, these are the two things that we needed to do on our local machine in order to run the app. So let's say actually I didn't go ahead and install all of the dependencies. So let me go here and let me delete the package.json and as well as the package.lock. And let's say I'm a complete beginner to JavaScript and I do not know how to run the app. I was just told by other developers, here's the app. All you have to do is go to your terminal and run npm run start. And so let's just go here. Let's just say I go to my terminal and say npm run start, and right away I get treated with a bunch of errors and I need to figure out exactly how to debug. Now you can see here we can't find the module Express because we haven't installed it. Now maybe I'm super new to Node and Express and I don't even have Node installed, and I might get another error. And you can see the troubles that I can potentially have when trying to run an application locally. Now this is an extremely simple application, so you're probably not going to have as much trouble. But with real production grade applications, there's millions and millions of pieces going on. And sometimes it takes weeks to configure your local environment correctly in order to run it if you are not using Docker. So now let's just go ahead and start Dockerizing this application so we can get it up and running in a Docker container. All right, everybody, let's go ahead and get our hands dirty by Dockerizing this application and getting it up and running inside of a container. Now let's quickly take a step back and think about exactly what I said there. I want to run this application inside of a container. Now, how in the world is that container going to include all of the things that we need in order to run the app? Now, remember, in order to run this app locally on our machine, we needed to have Node installed and we needed to also install our dependencies. So somehow, some way, what we need to do is inside of that container, we have to tell it that we need Node and npm, and we also have to tell it that, hey, you need to install all of the dependencies inside of this package.json. Another thing that we also have to do is tell the container how to run our application. In order to run the application, we ran the script npm run start, which runs node index, but how in the world is the container going to know that? So what we need to do is leave a set of instructions for the container in order for it to run our application correctly. And that is exactly what we are going to do with a file known as a Docker file. So in the root directory of your application, we are going to create a Docker file, and the D is going to be starting with a capital D. And then over here, we're going to say Docker file like so, and it has to be called Docker file. And you can see right here, we have this nice Docker icon. So in here, we are going to leave the set of instructions in order to run our application correctly in a Docker container. Now what I'm going to do is I'm going to go ahead and write out all of these instructions, and we're just going to write them out, and we're not going to explain exactly what they do. But don't worry, in the next few videos, I'm going to go line by line explaining what each set of instructions is doing. So let's just go ahead and just quickly go through it right now. So the first set of instructions that I am going to say is from node Alpine. Again, if this doesn't make much sense, A-OK, not a problem. And then this next set of instructions I'm going to say is workdir. And then notice the capitalization here, and then over here it's lowercase. And then I'm going to say /user /source/app. And then I'm going to say copy dot and then run npm install, and then expose 3000. And over here, then we're going to have cmd. We're going to have this array. And then over here, we're going to say npm run start. So this right here, this Docker file is all it is that we need, all the instructions that we need in order to run our application correctly inside of a container. Now, of course, this doesn't make much sense to you at this point. That's fine. Let's actually go through line by line in the next few videos. In the last video, we have created this wonderful Docker file. However, we do not understand what any of these instructions mean. So in this video and the next few videos, that is exactly what we are going to do. We're going to go through line by line to understand exactly what each instruction is doing. And we're going to start with this line over here from node :alpine. So this right over here, what it does is specifies a base image. Now you might be wondering, what in the world is an image? Well, as I said, this file over here contains all of the instructions to run our node application inside of our container. However, we don't go directly from our Docker file to a container. Instead, what ends up happening is we get this Docker file and we build something known as an image. Now, the image is going to contain all of these instructions and is going to contain a build that we are able to utilize to execute a container. So this right over here is just the regular file of instructions. This over here is an executable file that contains the instructions to run this container. So that is what we are going to do. So this is just kind of a middle process. So we're going to build our image, and then from this executable file that contains the instructions that we have specified here, we are going to run our container. So over here, what we're doing is we're specifying a base image, and we're specifying the base image node. Now, what does that even mean? Well, let's actually look at another diagram. So this right here is our container. And what we need to do is somehow get node and npm installed inside of this container. Now, in order to do that, what we're going to need to do is add significantly more configuration to do that. Or what we can do is just get an existing image that contains everything it is that we need in order to run a node application. And there's a bunch of existing images that you can actually search up on Docker Hub. So Docker Hub is a repository for images, and one of the images that I have pulled up, let me zoom in here, is, well, the node image. And you can see it has over 1 billion downloads. And if I go over here and I just click on one of these node images, you can see that it is indeed a Docker file that we need to write in order to run a node and npm application. So instead of, well, writing this over here and just copying it inside of our Docker file, making it nice and long, well, it's already built for us. So what I'm going to do is I'm going to specify that node image. I want to use this node image. This is what I want to start with. I need the basics to run a node, an npm application. So by saying from node Alpine, eventually when we run our container, right off the bat, we are going to have node and npm, and that is going to meet the requirement of having node installed. Now you might be thinking, well, what is this :Alpine? So node is the base image. Alpine :Alpine is the version. So if we go back to Docker Hub, let me just even zoom one more time. You can go ahead and look at it. But over here, you can see all of the different versions of Node that we can have. Now, all of these different versions at the end of the day are going to make our application base image contain a little bit additional things. Now, I chose Alpine because it is the most lightweight. It has the bare minimum stuff in order to run a Node application. And that is just nice. It makes it nice and lightweight, and it could make our application faster. However, if you have other requirements, you could use other versions. And of course, you can go ahead and click on them and dissect the Docker file to understand what you want, or just search for these specific versions on Google. Again, I chose Alpine, which I might not be able to find here. So Alpine. So there's a bunch of Alpines, but we chose just Alpine on its own. So let's see if we can find that. So I guess we can't find it here, which is a-okay. It's somewhere here. I think when we specify Alpine, we use probably the most latest version. You can see here there's multiple versions of Alpine. So that's what we're using. We're saying that, hey, we want the lightest weight of Node for our base image. Alright, my good friends, now that we understand what this command does, let's actually go ahead and go through every other command in this video. So let's remember that this command is specifying our base image, and that way we have node and npm inside of our container. The next command is workdir, and then over here we have this directory that we are specifying, /user/source/app. Now, what is this going to do? Well, what this is going to do is create that directory inside of our container. So inside of our container, let's say that this is our container, and our container is going to have a lot of files and folders. It is essentially creating something that looks like this, a user/source/app. So this is what it is creating inside of the container. And this is going to be our working directory. So all of the code that we have over here inside of our application, it is going to live in the working directory of our container. Now over here, this can be anything that we want, but it is best to call it something unique like this so it doesn't clash with any sort of files and folders that exist already in the container. So it's nice to have a directory like this. Now, if we want, we can also have it be whatever. We can also have it be pickles if we wanted to, and it's going to create a pickles directory inside of this container, and that is where all of our code is going to live. But of course, we don't want to call it something like pickles. We want to call it something, more professional, like so. All right, so that is the working directory. Let me just go ahead and delete this for now. And the next command is copy ... So what does this mean? Well, what this means is we want to copy everything inside of this application over here. So this file, this directory, and we want to copy it into the working directory of the container. So what do these ... means? Well, right here, this is where our Docker file is living. So it's living in the root. And what we want to do is we want to copy the index.js as well as the package.json inside of this local directory inside of the working directory of our container. So what we're going to need to do is specify, well, what files we want to copy. Well, we want to copy anything in the root directory. And that is exactly why we say dot. Now let's say we want to copy everything in maybe another directory. So let's say these two files, let me go ahead and copy them, are actually in here. Now I don't want to actually add another directory in there. I just want the files that are in there. So what I would do here inside of the package.json, because it lives right here, is say ./another. So I want you to copy everything inside of the another directory in my file system inside of the working directory. So inside of this working directory. So it would look something like this at the end of the day. So copy ... You can see I get my package.json as well as my index.js file. Now, if I didn't want to specify ./another, what I could do is I can just add the Docker file inside of the another, or what I could do is, well, go back to what I had before, just have it in the root. So I can go ahead and delete that, and that way we can just have dot, like so. Now, what is this other dot? Well, this is going to specify, well, where do you want to copy these two things into the container? Now, by default, it is going to use the working directory. But we could, for some reason, want to add it in maybe /users /source /app /lathe for some reason. So I can go ahead and say /lathe. So copy it in there. But of course, I don't want that. I want you to copy it into, well, this directory. So we're just going to say dot. And that is the copy dot. Very important command to understand because, well, that's the only way that we're going to get our code into the container. Okay, so the next command, and this one you might pretty much understand. This is a relatively easy one. Remember, in order to run this application locally, we need to install all of the dependencies over here. So we need to install these dependencies, which is just really Express. But without Express, we cannot run our application. Now, if you look over here inside of the container, right now it just contains the index.js as well as the package.json. Now, I'm just going to go ahead and install this locally. So when I run npm install, then I get two additional files, or one file and then a directory that contains all of our dependencies. And this is what we need in order to run our app. So we need to somehow get these two things inside of our container. How do we do that? Well, we run npm install. And that is exactly what this command here is doing. It's running npm install. And as soon as we run npm install, we get our package lock.json as well as our node modules. So that right there is, for this Docker file, all it is that we're doing to add everything it is that we need to run our application inside of this container. So at this point, we have everything it is that we need. We have node, we have npm, we have our dependencies, we have our files. So we got everything. So what are these two files doing, or what are these two lines doing here? Well, for expose 3000, let's go back here to our actual application. You can see that we are running on port 3000. This is where we are running our application. So over here, what we're going to say is, hey, we want to expose 3000 inside of the container, because this is what we want to run our application in the container. So we want to run it in localhost 3000. Now, the last thing that we want to do is this command over here. So cmd npm run start. So at this point, okay, the image is happy. It has built everything it is that we need to run our application inside of this container. But as soon as it builds the container and it gets it up and running, it needs to run a command to run our application. Now, what is that command? Well, that command is npm run start, and it's in this unique format where we put each command, or each I guess word of the command inside of array, and we separate them by commas. So it's going to, as soon as it's done building the image, in order to run our application, it is going to run npm run start in order to have our application up and running inside of the container. So that is what it is doing. So I hope that is clear and just overall makes sense. So now what we need to do is, well, we need to run our application. So let's do that in the next video. All right, let's go ahead and run our application inside of a Docker container. But before, let's quickly remind ourselves the process that we need to follow in order to get that application running in that container. So right now we have our Docker file. So right here, and we have specified the set of instructions. But remember, we cannot create a container from a Docker file. With the Docker file, we have to create a Docker image that is an executable file that is able to run containers. So that is step number 1. We need to build an image from our Docker file. And luckily, this is actually a relatively easy thing to do. All we have to do is go to our terminal and write a command. Now, what is that command? Well, it's this one right over here. So docker build, this is for building the image, and then -t, the image name, and then dot. So let me quickly discuss exactly what's going on here. So first of all, Docker. We're using Docker. And remember, we already installed Docker. So we have that command right here. You can see there's so many different commands that we have. So we're using the Docker CLI. And now what we're going to do is we're going to say specify that we want to build an image by saying build. And then over here, this is an optional flag, but I'm saying -t is going to be whatever image name I want to call it. So over here, we are tagging the image with a name. That way we can actually easily identify it whenever we want to, because we can have multiple images running, and maybe I want to work with this image and not another. I can identify it with its name. And then lastly, over here, we have this dot. This is very similar to the dots that we see over here. They specify the directory where the Docker file lives. So if we run this command right over here inside of the demos directory, the Docker file is in that directory. So by saying dot, we're saying, okay, look into the root directory. However, if our Docker file was somewhere else, let's say again in like a pickles directory, instead of dot, we would just say dot pickles, saying that, hey, the Docker file is in there. So that is what the dot is doing. So let's go ahead and run this command. So I'm going to say docker build. Let me zoom in here. Docker build, and then -t to flag it. I'm going to call this app node app. And then I'm going to say dot to specify where my Docker file is. And now you can see we have a bunch of commands going on. Everything is going well. Now for you, it might take significantly longer, and that's because I actually ran this before, and Docker uses some cool caching that I'll talk about a little bit later. But if this takes a little bit longer, do not worry, just wait. Now we want to see if we actually ended up building our image. So let me go ahead and clear this. Now to do that, what we can do is just say Docker images. And over here, you can see a list of all of our images. So you can see we have the node app image, and it's tagged with the latest tag. It also give it an ID. It has specified when it was created. So I created this quite a long time ago, but for you, it might say like 3 or 4 seconds, and it says the size. So that's how we can see it. Now also, if you have Docker Desktop, you can go to Docker Desktop, and you can see over here, we have our image node app. So that's good. So over here, we have completed this step. We have built the image. Now from that image, what I want to do is I want to run a container. So what command do I do? Well, it's this command. Now this is an important command, and it seems really big right now, but it's gonna get even bigger. We're gonna add a lot of different things to the command. But over here, we're gonna say docker run and then -- name to specify a container name, so we can call it whatever it is that we want. Again, this is kind of similar to the tag over here, just allows us to uniquely identify the container. And then we're going to specify the image name where we want to build the container from. So we can have multiple images, but I want to build the container and run and build the container from the Node app image. So I'm going to say Node app here. So let's go ahead and do that. So I'm going to say Docker run. And I'm going to say name. I'm going to say my Node app. And then I'm going to say Node app for the image. So let's go ahead and run that. And there we go. You can see that it is running. So it says now running on port 3000. You can see it consumes your terminal. So now you actually cannot write any more commands. If you want to use your terminal, you're probably going to have to open up another one. Now, in order to actually see that this is running, well, over here, you can clearly see that it is running, but you can also say Docker PS to get a little bit more information. Let me zoom out of here a little bit. This might be a little small. Let me zoom in once more. You can, oh my goodness, this is not looking good. All right, hopefully you guys can see this. Do it yourself so you guys can see it as well. You can see we have the container ID. We have the image that it was built from. We have when it was created. We also have the port that it's running on, which is 3000, and then the name of the image. So we have all this information. And also over here, if I go to the container, you can see I have my Node app up and running. So it is successful. So let me go ahead and access it. Well, that's amazing. I'm going to go ahead and access my application on localhost 3000. So let me go ahead and press enter. And wait, what? Why is this not working? It clearly says here that this is working. PS says that there is a container up and running on port 3000. And similarly over here, we have a container up and running on port 3000. Why am I not able to see it in my browser? Did I do something wrong? Well, no, you didn't do anything wrong. This is actually the expected behavior. So let me go ahead and explain why in the next video, and actually how we can get it up and running on localhost 3000 by adding a special configuration. In the last video, we noticed that when we go to localhost 3000, we don't see our application up and running. In this video, I'm gonna explain why. So currently, this is the setup that we have. So we have the container and we have our local machine. Now remember, the container is a completely separate environment than our local machine. So we are currently running our Node application on port 3000 inside of the container, not in our local machine. Our local machine has no idea what is going on right over here. And that's why when we go to localhost 3000 on our local machine, we don't see anything. Because again, the container is a separate environment. So what can we do to fix this? What if we are developing and we want to run our application in the container and we do indeed want to see it inside of the browser? Well, we do this with port mapping, and it is as simple as adding an additional flag. So this is the Docker run flag in order to run a container. So we have Docker run -- name, my Node app, which is the container name. And then over here, we have the image. But right here, we have added an additional flag, -p. This right here is for port mapping. And over here, we say 3000:3000. So what this is doing is this 3000 is referring to any sort of port on my local machine. I can call it whatever it is that I want. I can have any number. It could be 4, it can be 5, it can be whatever. This over here is the port inside of the container. And this should be the port that our application is running in. So what we can do now here is map 3000 on my local machine to 3000 inside of the container. So what it would end up looking like is whenever I go to localhost 3000 on my machine, it execs into this container, it gets all the content from the container, so it goes into the container, it goes into the process that's running on localhost 3000, gets the content, sends it back, and then it is displayed right over here on my local machine. And that right there is port mapping. Now this right here doesn't have to be 3000. This one does because our application is running on port 3000. But if we want to go to, let's say, localhost 5000, we can just very simply change this to localhost 5000. And when I decide to go to localhost 5000, it's going to exec into this container, find the process that's running on localhost 3000 because that's specified over here, get the response back, and send it. In fact, just to prove it to you, that is exactly what I'm going to do. So let's go ahead and run this. So right now we have, if I do docker ps, we have one container running. We can actually have multiple containers running. Remember, they are completely isolated environments. So let's go ahead and do that. So what I'm going to run is docker run. And then over here, I'm going to specify the name. So I'm going to say my node app 2 because we already have a container running that's called my node app. This time I'm going to specify the port. So I'm going to say port 8000 on my local machine. I want to map it to port 3000 inside of this running container. And then I'm going to say node app as the image. Let's go ahead and run that. You can see now it is running on port 3000 inside of the container, of course. And if I were to go to, let's say, localhost 8000, there we go. We see that my app is up and running. How cool is that? Now that we got our application up and running on localhost 8000, as you can see here, our container is running and we have the port mapping correctly. Let's say I have to make a change to the app. Let's say the business requirement for this really complex API has changed, and instead of saying hello world with 1 exclamation point, we have to do it with 4 exclamation points. So what I want to do now is I want to go ahead and save this. And when I go back to my application, I'm going to go back over here. I'm going to do a refresh. And you can see that my application has not changed whatsoever. Well, why is that? Now, if you paid attention in the last video, the reason is extremely similar. So you made a change inside of your local machine. So inside of your local machine, you're inside of the demos directory, and you made a change inside of this index.js. Let's also say you added another file. This file is called bunnies.js. This over here is not going to be reflective inside of the container. The container is already created. It has this working directory with these files. So in order to get the changes up to date, what I would have to do is go ahead and build another version of the existing image that I have. So if I say Docker images, you can see I have this node app over here. So we're going to have to build now another version of it. So we're going to say Docker build, and then over here we're going to say -t to tag the name. We're going to call this node app. And then over here, I'm going to say :v2. So this is going to be version 2. And then over here, what I'm going to say is .like so, just to use that Docker file. So now what I can do is I can go ahead and execute this. It's going to take a little bit of time to run the npm install. We're going to look at a way to optimize this Docker flow a little bit better. So now what I want to do is if I do docker ps, you can see I am still running this over here. So what I want to do is I actually want to just shut them down and remove them and just restart from scratch. So in order to remove it, you have to first stop the container from running. So to do that, what we're going to do is we're going to say docker, and then over here we're going to say stop. Now you have two options here. You can say stop or you can say kill. So kill is going to immediately, completely without maybe like in like a millisecond, it's going to stop the container from running. Whereas with stop, what it's going to do is it's going to gradually stop the container, doing some additional things that it needs to do just for a safe stoppage of the container. So if you need it done immediately, you say kill. If you don't mind the wait, you say stop. I don't mind the wait, so I'm going to say stop. And then I'm going to specify the container name. I'm just going to go ahead and stop both of them. Why not? So I'm going to stop this one, and I'm also going to stop this one. So now if I do docker ps, you can see I have no containers. However, the containers still exist. So if I actually go over here and I go to my containers, you can see that they still exist. However, they're exited. So now what we want to do is we want to remove the container. So we can say docker remove. And then over here, or rm for docker remove. Let me zoom in here just in case you guys don't see this. And then I'm going to say my node app for the first one. And then I'm going to specify the second one, my node app 2. And now you can see they have been completely removed. You don't even see them here at this point. So that right there is removing it. Okay, so now what I want to do is I want to rebuild this image, which I believe I did already. So if I go to my images, you can see I have this node app with this version 2. So I'm going to build a container based off of, build and run a container based off that. So I'm going to say docker run, and then I'm going to say port mapping. Let's say port 8000 to port 3000. And then over here, we're going to specify node app, but this time version 2. So that is the command that we're going to run. We can also specify, we don't necessarily have to specify a name, but I think it's a good idea to. Let's just call it my node app like so. And okay, so that's pretty much it. So let's go ahead and run this. Now it's running on port 3000. And now, there we go. We have seen the changes. Okay, so you can actually see that this is kind of a terrible process. So let's say I made a mistake. Oh no, I added, 4 exclamation points when it really should have been 3. Now I have to go rebuild the image. And then I have to rerun the container. It's just an impractical process. So what we need to do is we need to somehow, let me go back to my diagram here, somehow sync up everything inside of this directory inside of the containers working directory. So anything over here, I want to sync it up with anything over here. So how are we going to do that? Well, we're going to do that with volumes and bind mounts. And I'll talk about that in the next video. In the last video, I said that we need to find a way to sync all of the files and folders inside of the demo directory, which is in our local machine, to the working directory of the container. And I said that we are going to do that with bind mounts. And in order to do that with bind mounts, this is the command that we are going to execute. So we still have our docker run, this is our container, this is our image, and this over here is our port binding, but this is the new command that we have. This right here, -v, is specifying a volume. Now specifically for this, we're using a volume called a bind mount. And what it's going to allow us to do is sync all of our stuff here into the container. Now what does this mean? So over here, you can see that we have two different parts to it. We have this part here, and then we have this part over here. And they're separated by the colon. And it's extremely similar to the port mapping over here. So remember, this is the port inside of our local machine. We're mapping it to the port inside of the container. Over here, what we're doing is we're specifying the directory inside of our local machine. Now, pwd is just a shortcut to do that. So we could, what we wanted to do, we could just go over here and copy the relative path, and we could add, let me go ahead and just, I don't know what I did there. Let me go ahead and copy the relative path again, paste that in there. It's not really showing up. Let's go ahead here, copy this relative path. And we could, why is copy path, not relative path, sorry. So we could specify the path like this. So this is one way that we can specify the path to the directory inside of our local machine. And this has to be the absolute path. Now on Mac, we can just actually do pwd and it specifies that for us. So over here, what we're doing is we're specifying this path right over here. We want to link it to this path, and this path is the working directory. So what we want to do is, well, anything over here, we want to sync it up with anything over here. So in essence, is what happening is this right here, the code here is actually overriding everything inside of the user/source/app. Now let's go ahead and run this command. I'm going to use the shortcut to run this command, of course. Now, if you are on a Mac or Linux, this should work for you. However, if you are on a Windows device, this pwd is not going to work for you. So instead, what you can actually use is, I believe it's %cd%. I believe that is the equivalent. And if that doesn't work, you can just go ahead and copy the absolute path to your directory and just paste it in here. So that would work just the same. So let's go ahead and create this now. So I'm going to go ahead and save this. And what we're going to do now, I'm going to exit out of this. And I am going to run another container. Let's just call this my node app 2. And this time I'm going to have that bind mount. So I'm going to specify, like it says over here, $, $, and then what do we have here? Parentheses, pwd, colon, and then, well, where do we want to mount it to? The working directory, of course. So let's go ahead and paste that in. So this is looking good. Let's just go ahead and run this. And as soon as we run this, we're actually getting an error. And I expected this error. So over here, you can see that we're getting this cannot find module express. You know, that is a relatively strange error. But if you think about what is happening here, it actually makes a lot of sense. Let me explain it in the next video. In the last video, we applied our bind mount and we got this error over here. So it cannot find the module express. Now this actually makes a lot of sense. Let me go ahead and explain why. So let's remember inside of the Docker file what we're doing. So over here, we're copying the content inside of the working directory, and then we are doing npm install. And this right here is a very important step because right now inside of our directory, we do not have the node modules, nor do we have the package.lock.json. So what we're going to do is we're going to copy these 3 files into the working directory, but we still don't have the dependencies needed to run an Express application. And that's why the very next step is to run npm install so that inside of the container, we get the node modules and then the package.json. And as soon as we have the container up and running, we can go ahead and run it with this command over here, npm run start. Now this is how it is going to look like if we don't have any bind mounts. But we do have a bind mount. And this right here is exactly how our directory looks like. We have the index.js, package.json, and the Docker file. No node modules, no package.lock or -lock.json. So what we're going to do, because of our bind mount, we're just going to take everything in this directory and we're just going to go ahead and override it with this stuff. So inside of the container, we just lost our node modules. That is not good because without the node modules, we cannot run our Express application as we are using it over here. So what we need to do is somehow, when we want to sync our content together, what I want you to do is, hey, if there is a node modules in here, I want you to just leave that alone. Sync everything else, but leave the node modules as is. And we can actually do that with another volume known as an anonymous volume. So let me go ahead here and actually execute it. So we're going to keep our volume here. So let's just go ahead and just create another container. Now we're going to have Docker run name. We're still going to have our port mapping. We're still going to have the bind mount, but we're also going to specify another volume known as an anonymous volume. Why is this an anonymous volume? Because remember how volumes typically work. We have a colon. The thing on the left is going to specify the directory on our local machine. The thing on the right is going to specify the directory on the container. But over here, what we're going to do is we're going to completely get rid of that colon, and we're just going to specify a directory inside of the container that we want to leave untouched. And that is going to be, well, the node modules once we have them installed. So that node modules, where is it going to be? Well, it's going to be inside of the /user/source/app/node modules. Now over here, this is an anonymous volume because we're not linking it to anything. All we're saying is, hey, we want to leave this completely untouched when we're syncing things together. So let's go ahead and now give this a quick run. And there we go. You can see now our application is running on port 3000. You can actually see we have a node modules directory. Now there's nothing in here, but inside of the container, it is completely untouched, everything in it. And just to prove that, we can actually exec into the container. So we can actually SSH into the container itself. Because remember, the container is, in a sense, a computer on its own. It's its own operating system, its own virtual machine. So to actually go into it, we can do docker exec/it. And then we're going to need the container name, which is going to be my node app. So it's going to be my node app 3. And then I'm going to say /bin/sh. Now this is what it is for me on a Mac. If you want, what you can do is you can just very quickly click the CLI button and it's going to run it for you. So that's just a little trick that you can do if that doesn't work for you. And this is 3, by the way, not going to be 2. So let's go here. Let's go ahead and exec into it. Now we are actually inside of the container. So if I do ls, you can see I have a Docker file, I have my index.js, and I have my package.json. So I'm going to go ahead and go to my node modules, and if I do an ls, you can see I still have all of the content because of that anonymous volume. So enough of that. Well, we have just created this wonderful volume, and we should, let's go back here, we should have our application running on localhost 8080. Let's go ahead and make a change and see if this works. So I'm going to say hello world. You know what? I'm going to say goodbye world. You know, it's too many hello worlds out there. Goodbye hello. Goodbye world. I'm going to go ahead and save this now. I'm going to refresh and wait. It's still not working. I thought we were syncing everything in here to our container. Are we not doing that? Well, let's actually go to our exec over here. And remember, ls. So you can see we have this index.js. And this is the index.js that is inside of the container that is currently running. I'm just going to say cat index.js just to see the contents inside of here. So over here, you can see the content. And you can actually see goodbye world. So yes, indeed, it is actually changing the content inside of my container. This bind mount is indeed working. However, well, it's not working in here. Why is that? Well, I'll tell you in the next video. So far, we have done a lot of tremendous work with bind mounts and anonymous volumes, but our application, it isn't updating at all still. And this actually isn't Docker's fault at all. This is actually something that is native to Node and Express. So let me just go ahead and try to run this application locally again. So I'm going to go over here. Let's just close out of this. And I'm just going to do an npm install to install all the dependencies, because remember, I do need that. So let's install the dependencies. And over here, as you can see, we have the dependencies and all that. And I'm just going to go ahead and run npm run start like so. So now we are running on localhost 3000. So localhost 3000. You can see here we get goodbye world. Now if I go ahead and decide to change something, let's add more exclamation points. Let's save that. And I refresh, you can see that it isn't, well, updating, even though I updated this file. And that's because anytime we make a change inside of a Node application, what we need to do is to restart it and then, well, just restart it. So close it out and then restart it, and then we see that change. And that is exactly why we are not getting any change here. We have to restart our Node server every single time, which we are not doing in the container. Now, of course, we do not want to restart our Node server every time we make a change. So what we can do is we can actually utilize a dependency called nodemon. So this is a great dependency that we can utilize. Let's go over here to our package.json, and it's going to listen to any changes inside of our files, and it's going to automatically restart our Node application for us. So over here, let's define a new dev dependency, because we're only using this in development, and it's going to be called nodemon. And I'm going to use the version 2.0.16. Let's go ahead and do an npm install just to get that installed again. So Control C, npm install. Let me zoom out of here a little. Close out of that. All right, so now we have nodemon installed as a dev dependency. So now what we can do inside of our package.json still, I'm going to add a new script, and I'm going to say we want to start this in dev. So start :dev. I'm going to say nodemon index, like so. Okay, so that is pretty much all it is that we want to do. So next time what we're going to do is we're going to run npm run start :dev, and you can see now we get this. And if I were to go to the app, this is on localhost 8000 in the container. You can see here we have goodbye world. And now if I make any change, if I refresh, you can see automatically we get it there. So that is what we need to do. And we actually already did it. So over here, what we just need to do now is just build our image again, because we have a package.json and we have made some changes here. And we need to run a container that runs this script over here. So start :dev. Now the issue is our Docker file is running npm run start, not npm run start :dev. So you might be thinking, well, this is an easy solution. I can just add :dev, and that would be completely viable. However, we might need this Docker file if we want to run our application in production. So we don't want hot reloading in production, because in production, we're not going to be making any changes. So we might still want this Docker file for, well, prod. And that is actually a-okay. We can leave this one for prod. And what we can do is we can create another Docker file specifically for dev. So let's go over here. I'm going to create a Docker file, and then I'm going to call it .dev. You can call it whatever it is that you want, but I'm going to call it dockerfile.dev. And then over here, I'm going to copy all this content, paste it in here, except we're going to have :dev at the end of the start. And we're going to use this Docker file anytime we want to build our image. Okay, so let's go ahead and do that now. So over here, you can see we're running on port 3000. Looking good, looking good. So I'm going to go here. And I am going to say, let's go ahead and build this image. So we're going to say docker build. And I'm going to say node-t. Let's just call this, let's just have this be another version. So let's go to over here. I forget what we called it. So I'm just going to say node app. And then I'm going to say :v3. So it's going to be another version. And then what we want to do is specify that we want to use the dockerfile.dev. Because by default, what ends up happening is it looks into the root directory and it just looks for a Docker file. So what we want to say is, well, we don't want to look for a Docker file. We want you to use a dockerfile.dev. So to do that, what we say is -f dockerfile.dev. So let's go ahead and build this now. All right, so you can let's go ahead and just check that it's built. We have version 3. Let's just go ahead and I want to just delete every single container here, every running process. So I could do it in here, but let's do it with the terminal. So I'm gonna say docker ps. So we have this running application here. So let's just grab the name of this, and let's just say docker stop. I want to stop this. Now if I do docker ps, you can see that nothing is running. So now what I want to do is docker remove. I want to remove this container. I want to remove this container. And I want to remove this container. So now we have removed all the containers. You can see we have nothing here. The images will just leave. We won't remove them as of yet. So now we have no containers. So now what we can do is, let me go up here. Now what we need to do, I don't want to run that. I don't want to write that whole command again. And of course I'm talking about the whole bind mounts, but you know what? It might be a good idea to do that just for practice sake, just for muscle memory. So we're going to say docker run. And then we're going to specify the ports. Let's just say port 8000, syncing it to port 3000, -v. And then let's do the bind mounts now. So we're going to say pwd. And then over here, we're going to say : the working directory, which is user/source/app. Let's also specify the anonymous volume, user/source/app/node_modules. And then we need to specify the image, which is going to be node app. And then this is going to be version 2. So v2. I believe that is what we called it. Yes, or sorry, we want v3 here. So v3. Okay, so that is all it is that we need. We don't have a name though. So let's just give it a name at the very end here, --name. Let's just say my node app. You can call it that because we deleted all the others. So let's go ahead and execute this. You can see now it is actually running with nodemon. So if I go to localhost 8000, you can see that this is what we get. Now let me go ahead and make a change. Get rid of this for now. If I do a refresh, there we go. There we go. This is inside of the container. We're able to sync it inside of the container. So, well, congrats. This was actually a relatively tough thing to understand. So if you got through it, congratulations. In this video and the next few videos, we're going to look at ways where we can optimize our Docker workflow. In this video specifically, I want to remind you that inside of our local machine, we did an npm install. And let's say this is an application that is utilized by many developers. Some people don't do an npm install, they just run the Docker command. Some of them do an npm install, and thus they have the node modules as well as the package lock.json file inside of their directory. Now let's say those people, they decide to create an image based off this directory. What is going to happen here? Well, based on the Docker file, we're going to go over here. We're going to specify a base image. We are going to go ahead and specify our working directory. And then here, we're going to copy everything inside of this directory into the working directory of the container. And this is going to include this humongous node modules directory that contains all of our dependencies. And this is going to make this step over here really, really slow. And then to make matters worse, after we got everything in there, we're just going to go ahead and do an npm install to install all the dependencies again, which is already a very slow step. And then of course over here, this is going to be exactly the same. So ideally what we want is, well, if you have node modules inside of your directory and you want to build an image, we do not want to copy that node modules in. So we do not want to copy it into the container. We want the container to create it by running an npm install. So that is what we want to do. And also there are some other things that we might not even want inside of the container at all. Like the Docker files. There's really no purpose for the Docker files to be inside of the container. So one thing that we can do is just completely ignore these. And over here, of course, there is no step to create those Docker files, so they won't be in the container. And we can actually do these things with a very special file called .docker ignore. So over here, what we can do is specify all of the things that we want you to ignore and not copy into our container. So I'm going to say node modules, and then I'm going to say also the Docker file, also the Docker file.dev. And then over here, let's go ahead and say the package-lock.json. So these two things just won't even exist in our container, the Docker files. And then the node modules, we're not going to copy them over, but then they're going to be created in this run npm install step. So let's actually go ahead and rebuild our image. So let's go here and let's go moi. It's going to rebuild our image. So Docker build. And then over here, I'm going to say -t. I'll say node app v4. Now, before I do that, I'm inside of my Docker. I want to exec into the Docker. So let's just say Docker exec. And then this is inside of the container. So it. And remember, our running container is my node app. So I'm going to say my node app /bin/sh. So over here, if I do an ls, you can see we do indeed have the Docker file and the Docker file.dev. So I'm going to go ahead and just build this now. So let's see if it built. Nope, something went wrong here. We got an error. So one argument. So Docker, oh yeah, we also have to specify dot. So let's go ahead and build that now. So you can see the copy command was relatively fast because we ignored the node modules. And the npm install, of course, is going to take some time. Let's give it some time. Man, 20 seconds, guys. I wasted 25 seconds of your time. 26 or 25 seconds or 27. What am I saying? 26 seconds. Okay, so now I'm just going to do a Docker run. I'm not going to have any ports because I'm just going to exec into this. So I'm going to say Docker run. I'm going to say --name. I'm going to say here with ignore. And then over here, we're just going to say the node app version 4. So let's go ahead and run this. You can see here that it is indeed running. So I'm going to exec into this. So let's just go ahead, exec -it. I already forget what it was called. It was called with ignore. That's what it was called, with ignore. And then what we're going to do is going to do /bin/sh. We're going to exec into it. And now if I do an ls, you can see I do not have the Docker files in there because they were not copied in with the git ignore. Now we do indeed still have the node modules as well as the package.lock. Again, that is because, not because we copied them in there, but because we ran npm install. And that's why we have them in there. So that is way more optimal, and we can actually go ahead and ignore things we do not want inside of our container. In this video, what we're going to do is truly understand how an image is built. That way we can understand how we can optimize our Docker workflow. So let's look into it. So this is how Docker builds an image. It builds an image with layers. So each command here you can consider a layer. And with each execution of the command, it changes the overall image that it's trying to build in some way. So over here with this command, it's going to change it in one way. Over here, it's going to change it in another way. It's going to add a working directory. And then over here, it's going to change it. So with each layer, it's going to change the Docker file. Now, why is this important? Well, with each change, it is going to store that change in memory. In essence, it is going to cache those changes so that if we ever run this Docker file again, it is not going to do this from scratch. What it's going to do is going to say, oh, I've already executed this layer and I know the changes are going to look like this. So let me go ahead and grab it from in memory. And it's going to do that same for here, same from here, same from here. So in essence, it is going to cache the results of the Docker file, which is going to significantly speed up the process. Just to prove it to you, this Docker file has already been built. So let's go ahead and build it again. And let's just look at the process a little bit more this time. So I'm going to go here. I'll get rid of some of these Docker stuff. Let's just go ahead and build a brand new image. So Docker build -t new image. And then over here, I'm just going to say dot, like so. So let's go ahead and build this image. And as you can see here, all of the different processes. So over here, I don't know if you can see the from node Alpine. I guess we can't see that. But you can see here, it's cached. This is cached over here. This is cached over here. So you can see that the process of building this was relatively fast. So this is pretty good. Now let's actually say I go ahead and I make a change to my index.js. I add, more exclamation points. And now let's say I want to rebuild my image. Now, of course, in this step over here, the copy ... the process has changed. My code has changed. So I don't want to use the cache at that point. What I want it to use is to actually rebuild it and do the copy ... So I'm going to go ahead and let's just say v2. Let's build this again. And you can see right away that Docker is actually smart enough to say, hey, this is not cached. So it's not going to cache it. The code here has changed. It's not going to cache it. It's going to restart the step. But also notice that the run npm install step also ran again. And this is a relatively expensive step. It takes a really long time. Let me go ahead and just show you again. I'm going to go ahead and make a change. Let's do v3. You can see here that this step over here has not been cached. And also this step has not been cached. We are rerunning this step. And you can see how long it is taking. And that is actually not very efficient. So this is what was happening. We make a change. What it's going to do is going to cache these two steps. But this step, there is a change here. So it's not going to cache this step. And then what it does is it doesn't cache any of the other steps below it. Now, in this case, we haven't made any sort of dependency change. We just made a change in the code base. So there's really no point of doing an npm install again. The only reason why we would ever want to do an npm install is if we make a change to our package.json. Maybe we add another dependency. That's probably the only reason why we'd want to do it. So there's an actual way that we can improve this workflow, and it looks like something like this. So over here, instead of copying ... and then running npm install, the first thing that we're going to do is copy the package.json into the container. And if everything is the same, it's not going to go ahead and run npm install. And then we are going to copy ... So let's say we make a change to our code base, but now not our package.json. This step is going to be cached. This step is going to be cached. This step is not going to be cached, but this step is very quick. And then these other steps are also very quick. So that way we actually avoid running npm install anytime we make a code change. Now let's say we do make a package.json change. Well, in this case, we actually do want to run npm install. So that is okay. So it would look something like so. All right, so let's go ahead and do this now. So I'm going to say, instead of copying everything, copy first the package.json into the working directory. And then here, I want to run npm install. So let's open up the terminal. So now what I want to do is let's build another image here. Millions and millions of images, v3. So let's go ahead and build that now. So the first go round, it is going to go ahead and not be cached. That is a-okay though. That is expected. So that's the first go round. Just wait. There we go, looking good. And now I'm going to make a code change. So now look how much faster this is going to be. So let's go ahead and build another image. Look at that. Look at that amazing workflow. How fast is that? So this was cached because it was unchanged. This was cached. And then over here we have copy ... Now let's say I decide to downgrade the version of NodeMon. Well, in this case, we do indeed want it to not be cached. So I'm going to say version 6. You can see now we're running the npm install again because this step is not going to be cached. I'm actually going to go ahead. Let's wait this out. Let's build it right over here. And I'm going to move this right back to version 16. So I want you to think, is this going to be cached or not? So let's just go ahead and build another image. And it's actually cached. So Docker is actually smart enough to understand. So it's not just the latest version. It's any version that we have created. Docker is able to understand that we already had 16 and it is able to cache it. So it's nice and quick. So that concludes the lecture on the Docker file, images, and containers. I hope this is nice and clear, and I'll see you guys in the next section. In programming, the best thing that you can do in order to truly understand a topic is to do something on your own. We don't want to be stuck in tutorial hell. And that's why I have this challenge. In this challenge, you are going to be Dockerizing a completely new application on your own. This is so new that it is not even in the same language. So previously we did it with Node and Express, which is in JavaScript. This over here is going to be a Golang application. So attached to this video, I have a zip file. Go ahead and unzip it, download it and unzip it, and then open it up in VS Code. Over here, you can see that we have a Go application. Now inside of this Go application, we have this instructions.md. Now in here are just a set of instructions of the things that I want you to do. So let's go ahead and quickly go through them. So the first thing that I want you to do is I want you to create a Docker file for this Golang REST API. So that's the very first thing that I want you to do. Now, in order to create the Docker file for a REST API, you're going to need to know some Go commands, and I don't expect you to be a Go expert, so I gave you some hints right over here. So this really is all the information that you need in order to Dockerize this app. So the first thing is the go.mod and the go.sum. They are dependency files. So they're very similar. These two files over here are very similar to the package.json that we had in the last section. Now, in order to install the dependencies, you run go mod download. So that is what you execute. In the last video, we ran npm install, and that installed all the dependencies in the package.json. So that is the equivalent. Now, to run the application, we did npm run start. To run this Go application, we run go run main. And this application is going to be running on port 8080. And you can see that here. You don't have to, but you can go over here and you can see that it is indeed running on port 8080. Looking good, looking good. So that's the very first step. And this is all the information that you truly need in order to do it. So once you create your Docker file, then I want you to ensure that when the container is up and running, I want you to make sure that this file, this instructions.md file, as well as the Docker file, don't make it into the container. Don't make it onto the container. So that is something that I want you to ensure. And we've covered this already. I'm not going to tell you. You guys can figure it out on your own. And then step number 3 is I want you to build the image. So I want you to build the image and I want you to tag it with the name Golang app. All right. And then once we build the image, I want you to run the application in a container with the correct ports and volumes. So I want to be able to access it in my browser. And I also want the ability to make changes, and I want to see it inside of my browser. So another thing that I want you to try to do, and we actually didn't learn this, but this is maybe something that you can do on your own for research purposes, is try to run the container without it consuming your terminal. So remember when we always ran the container, it consumed our terminal? Try to figure out a way to run it without consuming our terminal. I'm going to give you a quick hint. It is just going to be a specific flag that you have to put in your Docker run command. Now, another thing that I want you to note, so this is kind of a hint, and this hint is going to make, at least the volumes a little bit simpler. Over here, the result of go mod download is not going to result in any additional files and folders in our directory. So remember when we did an npm install, we got the node modules directory, and we also got the package.json lock directory, and we had to account for those when we were working with volumes. Well, we might not have to account for that when we do a go mod download because we're not getting any additional files and folders. All right, so that is that. And then, well, over here, after we run it, I want you to immediately stop the container, and then I want you to remove it, and then I want you to remove the image. So that is pretty much it. I hope this is nice and clear. Please, please, please give this a shot, and I'll see you in the solution in the next video. Hopefully you guys gave that a go. I'm going to go ahead and give you the solution in this video. So let's start off with step 1. Create a Docker file for this Golang REST API. So the first step is to, create a Docker file. There we go, all created. So inside of this Docker file, the first thing that we want to do is to specify a base image. Now, in order to run this application, we need to have Go installed. Now, instead of doing that ourselves, again, we're going to specify a base image. But now, what base image will we have to utilize? Well, we're going to go ahead and Google that. So I'm going to say Golang base image. And I'm going to go over here to the Docker Hub repository. And there you go. You can see that there is a Golang base image that we can utilize. And over here, you can see all of the different versions. We're going to be using Alpine. You can use whatever it is that you want. I'm going to use Alpine. So let's go over here. Let's just say Golang and then Alpine. So that is step 1. We have specified our base image. The next thing that we need to do is specify our working directory. I'm going to have this be /app/source. So that is what I am going to do. The next thing that we need to do is we need to copy, well, the go.mod as well as the go.sum file into our working directory. Now remember, we want to copy these first before we copy everything else, because we're going to do a download here, go mod download, which will install all of the dependencies. So this is just more efficient for cache layering. So I'm going to say here, copy, and we can either do this if we want to. So we can copy go mod and then copy that into our working directory. And then over here, we can say go.sum and copy that into my working directory. That is completely fine. Or what we can do is copy, and because we want to copy all of the files that start with go, what we can actually do is just a regular expression. So we can say go.star. So any file that starts off with go dot, and then the extension can be whatever it is that we want to go ahead and copy it in there. So that just saves us one line. So it's a little bit better. And there we go. Now you learned a little something new. So the next thing that we want to do is once we install everything, we're going to go ahead and run go mod download. So download, that's what we're going to run. And then we want to copy everything else into our working directory. Okay, looking good, looking good. Now this is running on port 8080, so let's expose 8080. And lastly, as soon as the container is up and running, this is the command that we want to execute. Go run, and then main.go. Looking great. So we're done with this. We have created our Docker file. Now what we want to do is we want to ensure that this instructions.md as well as this Docker file don't make it onto the container. Now remember, over here we're copying everything over. So what we can do here is we can add a docker ignore, and then in here I'm going to say instructions.md, and I'm also going to say the Docker file itself. I don't want it inside of the container. So that is good. Now what we want to do is we want to build this image and tag it with the name Golang app. So let's open up our terminal. All right, so let's open that up here. Let's get rid of that debug console. So we're going to say docker build for building. And then I'm going to say the tag of Golang app dot. So let's go ahead and build that. And for me, it's going to be pretty fast because I have a lot of caching. I've done this before. For you, it might take a little bit longer. But now if we do docker images, we should see that we have this image that was created 12 seconds ago. All right. And of course, you can pause the video if this is going a little too fast so you can catch up. So now what we want to do is we want to run our container. Now we want to make sure that the ports map as well as we have the volumes. So let's go ahead over here and we're going to say docker run. And actually, one thing that I missed is that we want to try to do it without it consuming our terminal. So I'll note that as well. So we're going to say docker run. And then over here, we're going to say, I want to link 8080 on my machine to 8080 in the container. We're also going to have a bind mount volume. So I'm going to specify my working directory and then specify the working directory here. All right, that looks good to me. So that is the volume. And then we need to specify, of course, the image. And then I want it to run without it consuming my my terminal. So what I'm going to do is I'm going to add the flag -d for detach. So I want to detach this. So let's go ahead and give that a quick run. And you can see now it does not consume my terminal. And if I do docker ps, you can see that I do have an application that is up and running. And it also, if I look at here, you can see if I go to my container, I have this application up and running. Now, because I set up my ports, we can go to localhost 8080. We can see that we have you can see that we see it. It works. So now what I want to do is I want to test out the volumes. So over here, let's just say goodbye. Goodbye. Let's save it. And let's go over here. And you're going to notice, at least for me, it's not going to refresh. This is going to be a similar problem in that anytime we make a change, we have to restart our Go server. In order to fix this, we would have to use the equivalence of nodemon. But indeed, the volumes do work. So to prove that, what we can do is we can actually exec into this container. We can do that very simply by just going to our desktop. And then this is going to open up our terminal. Let me go ahead and zoom in here. So it's going to exec into it. Now, if that doesn't work for you, what you can do is you can just do docker exec it. And then over here, you can either use the name of the container or this ID and then / bin. And then I'm going to do an ls. So one thing that is odd is the instructions.md file is in there, as well as a Docker file. Did it not ignore it? Oh, I think the reason why this happened is because of the caching. So that's pretty unfortunate. But let's just go ahead over to the main.go. So I'm going to say cat main.go. And then over here, we should see goodbye world rather than hello world right there. So you can see it is indeed working. Now, this is the way to ignore files. You just put everything in a Docker ignore. I truly believe it's because of the caching, and that's why we actually do end up seeing it. So again, that's pretty unfortunate, but it is what it is. All right, so now let's move on to, we're done this step. We learned how to do it in detach. So now what I want to do is immediately stop and remove the container. So to immediately kill the container, well, we're going to use, rather than docker stop, we're going to use docker kill. And we're going to specify the name of that. Now the name of it was auto assigned to us. So charming_charson. For you, it's going to be different for sure. So charming, actually, you know what? I'm going to say docker. Well, you know what? I already did docker ps. So I'm going to say docker kill. And I'm going to kill charming Carson. Now if I do a docker ps, we have no instances. So then I'm going to do docker remove charming Carson. And now you can see we have no docker. And then I'm going to say docker images, because that's what we want to do. We want to remove the image. So we want to remove this one. So I'm going to say docker image remove. We want to remove this image. Now that got deleted. If I go over here, you can see it's all gone. Okay, so hopefully you guys did this challenge and you were able to successfully go through it. And I'll see you guys in the next one. Now that we have learned exactly how to build an image and to run a container, let's get our application deployed so that the world can go ahead and use it. Now, in order to do so, we're going to be using a great platform called Control Plane, which is an excellent platform for deploying containerized applications. It makes it really, really easy to deploy these applications, as well as it comes with a lot of great features that you don't get right off the bat with other cloud providers. So let's get into it. Now, in order to run our container, that container needs to run on a machine. Even though the container is a completely separate environment from that machine, it still needs to be run inside of some sort of machine. Now, so far, that machine has been our computer. So we've been using our computer to run the container. Again, the container is going to be a separate environment from our computer. That's why we can run a Node application without having Node installed, but it still needs a machine to run on. Now, if we ever want to get our application deployed, we're going to have to run our container inside of some server. And typically, we're going to utilize one of these three cloud providers to deploy our application. So either AWS, Azure, or Google Cloud. So these providers have multiple data centers all over the world with a bunch of different servers that we can run our container on. So typically we are kind of restricted on which provider we want to pick. We can either pick AWS, but we can't pick both of them together, Azure as well as AWS, or AWS and Google Cloud. We usually just pick one. Let's say we pick AWS, we pick a server as well as a data center location, and we run our container on that server. And so let's say over here we have multiple different data centers, and this is the one that we choose. We choose this data center over here, and we run our containerized application right over here. Now this seems great, but there are some potential issues with this approach. So let's say that a user that is located right over here in this side of the world wants to make a request to our server. Well, this actually isn't a big deal. The data center over here is not that far from the user, so they can make a request, get it back in a relatively short period of time. However, let's say that now we have a user over here that wants to make a request to our server. The distance between this user and this data center is a lot greater. So they're going to have to make a request all the way over there, get the response back, and that is going to take quite a bit longer. It is going to increase the latency of your application, in essence, making your application a little bit slower. So that is not great. Another thing that might happen, and this does happen, has happened to my company, is that a data center at a particular location goes down. And at that point, no matter where you are in the world, whenever you try to make a request, you're not going to get a response back, and that's going to render your application down as well. So this isn't a great approach. And this is what Control Plane is trying to solve. So Control Plane doesn't restrict you to picking just one cloud provider as well as one location. What it does is it deploys your containerized application in multiple cloud providers across multiple locations. So over here we have AWS, we have another AWS that's located in another location, and then over here we're deploying our application in a Microsoft Azure data center, over here Google Cloud, and over here Google Cloud. And here we have another data center that we are not deploying our application in, but if we want to, we can tell Control Plane to deploy it in here as well. So what's going to happen now is, let's say that same user wants to make a request. Instead of going all the way to AWS, Control Plane is going to forward that request to Google Cloud and send it right back. And that is going to significantly speed up our application, because look, the distance between the two is very small compared to over here. Now let's say that this user over here now makes a request. Well, it's going to go to AWS because that is the closest data center. So it's going to be significantly faster. Now let's say that AWS goes down. So this data center goes down. Well, no problem. This data center is down. We're just going to forward it to the nearest data center. So I'm not sure whether it's this one or this one. Let's say it's Microsoft Azure. It's going to go ahead and make a request and send it back. And then everything is A-OK. So this is what's great about Control Plane and why I want to show it to you. And it also comes with a lot of other great features. So automatic management of SSL, which enables HTTPS on your web server, which is a pain to configure on your own if you ever tried it. There's a simple command line interface for deployment. It has a great dashboard. You can view a lot of logs, just view your application in general. And you can set it up in multiple environments very easily. So you can have a staging environment, you can have a dev environment, as well as a production environment. And this is very, very easy to set up. So enough of that. Let us get into it. To deploy your application on Control Plane, go ahead and sign up for an account. Now, this is going to ask you for some basic information like your phone number, your email, your name, as well as where you live. It's also going to ask you for some credit card information. And that's because hosting a server on one of these cloud providers is not going to be free. So anytime we utilize a server, AWS or Google Cloud Platform or Azure is going to charge us a bit of money. And that's why Control Plane needs to have your credit card on file. Now, you're not going to be spending a lot of money if you decide to follow along, because what we're going to do is we're going to quickly deploy our application, and as soon as we see that it's up on the web, we're going to go ahead and terminate it so we don't use that server anymore, and so we don't incur any more costs. So you should pay little to nothing if you do indeed want to follow along. If not, that's okay. You can just continue watching the videos, and you can learn how to do it that way. Alright, so go ahead and sign up. It's going to prompt you to sign up with either Google, Microsoft, or GitHub. And once you sign up and you put all your basic information, which I already did and I do not want to do on screen here, you should see something that looks like this. So over here, this is the Control Plane dashboard. And by default, you have this tab open right over here stating your GVC. So let's quickly discuss exactly what a GVC is. So if you go to the documentation, I'm going to go ahead and just increase the size of this a little bit more. You can see here it says it is a global virtual cloud, and it defines a set of cloud providers and their locations. So let's remember that Control Plane, what it does is it doesn't restrict you to one cloud provider in one location. Instead, it allows you to deploy your app throughout multiple providers, throughout multiple locations. And so your GVC is exactly that, the set of cloud providers as well as the locations where your application is going to be deployed to. And you can see that over here. So if you go to your locations, you can see all of the different locations that once you deploy your application into, it's going to be hosted over here. So you can see here, this is in Europe, and the provider is AWS. This is AWS East Ohio. So US East Ohio, also by AWS. This one, AWS East West Oregon. And then over here, we have another cloud provider, Azure. So Azure Central US, Azure East US, and then we have Google Cloud Platform in some other location. Now, if you do not want a particular location, you can of course delete them. If you want another location, you can add it. Okay, so this is looking good, but now what we want to do is we want to deploy an application on this GVC. So to do this, what we need to do is somehow get the image that we have built for our node application over here to Control Plane. Because once we get this image to Control Plane, it can use that image in order to run a container. Let's discuss that in the next video. In the last video, we discussed that we somehow need to inform Control Plane about this image over here. And this is the steps that we have to do in order to do that. So firstly, what we need to do is we need to build our image right over here locally. And then what we need to do is push our image to an image repository. So we've actually seen this before. So if I go to dockerhub.com, this over here is an image repository. It's a place where a bunch of images are going to be stored. So over here, I can search for a node image. And as you can see here, we have this node image. And from these repositories, what we can do is we can start pulling images in if we need them. So this is what we need to do. And that is exactly what we are going to do. So we're going to go over here, and Control Plane has its own image repository where we can store all of our images. So that begs the question, well, how am I going to push the image that I've built on my local machine into this image repository? And by the way, this image repository is going to be private, so only Control Plane is going to see it. Now you can, if you want, push something that is public, like we have in a Docker Hub over here, so that other people can use it if they want to. That is completely fine as well. But this one's going to be private because, well, I don't want people having access to my Docker file image. All right, so let's go ahead and do that. So how do we push into our repository? Well, there is some documentation over here. So how to push an image. Let's go ahead and click into that. And the first thing that we need to do is we need to log in from the CLI into our account. So what we need to do is we need to install this over here. So CP, let me zoom in here a little bit. So I'm going to increment this a little. Over here, what we need to do is we need to install this command line interface into our terminal. So over here, what we're going to need to do is install it like so. So this is going to be an npm dependency, and you're going to need to have npm installed in order to do this. So you're going to do npm-g, and then over here, you're going to do @control plane-cli. I already did this, but once you do it, you should have access to the control plane CLI. I don't know if I said that correctly. Let's see here. Where is it? It's cplm. And over here, you can see there's a bunch of different commands that you can execute. Now, one of the commands that you're going to execute is docker image login --org, and then your organization name. And this is just going to prompt you to log into your control plane account. So let's just go ahead and do that. Let's go here and let us go grab our organization. So this right here is our organization. Let's grab that. Let's paste that in there. And that should just prompt you to log into your account. I'm actually already logged in, but what you should see is some sort of interface like this telling you to log in with Google or GitHub or whatever. So once you log in, that's great. That's really all it is that you need. Now what we need to do is, well, we want to build a new image. So typically this command right here should be very familiar. We've done this before. So docker build -t, and then we tag it with whatever we want to call it, and then dot. Now this is actually important here. So what we need to do is when we create this name, it has to follow this particular format. So our organization name that is in control plane, and then .registry.cplm.io, and then whatever our image name is called, as well as a tag. So it has to follow this format. This has to be the name, the tag of our image. So let's go ahead and do this actually. So I'm going to go ahead and build this off. And let's build it. And let's get rid of this now. And let's paste in my actual organization name. And then over here we have .registry, that. And then over here, I'm going to call this Node App version 1. All right, so I'm going to go ahead and build this image. And if I do Docker images now, so Docker images, as you can see, we have that image built, and it should also be built here. Looking good. All right, so what's the next step? Well, the next step is now what we need to do is, so we have our image. Now what we need to do is we can skip this step over here, but now what we want to do is we want to push our image. So it's going to be docker push and that particular image. And because we called it this way, so our organization name .registry.cplm, Docker is able to understand, oh yeah, we need to push this into control plane. And so over here, we're going to say docker push. So docker push, and then I am just going to copy this because that's our image name, and then I'm going to say :v1. All right, so let's go ahead and push this. All right, and this might take some time. Over here, it might take a little bit of time to push, but once we push it, then what we can do is, well, if we go over here or here to our images, and if I refresh, it's probably not done yet, but it should be there eventually. So as you can see here, it's going to take a little bit of time in order to do this. And it's almost done. I do not want to pause the video, so let's just wait this out. And we should see the image over here. Now, once we see the image over here, we can use it on this platform similarly to when we have built images over here. So we can just utilize this to run multiple containers. And that is actually known as a workload. So a workload over here, we can create a new workload, and that is going to utilize that image to run multiple containers throughout our GVC and all the GVC locations. So over here, if we create a new workload, we can call this whatever it is that we want. And then over here, we specify all of the different containers as well as their images. So let's just go ahead. Okay, it looks like it's done now. Let's go over here to our image, and there we go. You can see now we have our image. Look into it. We can get more information about it. We can delete it if we want to. Obviously, I don't want to do that yet. But now let's go ahead and, run a workload off of this image, and we'll do that in the next video. We pushed our image to this private image repository, so now we can utilize it to run and deploy a workload. So go to your image, click on pull, just so you can get the full name of your image over here. I'm going to go ahead and copy that. And then let's just say, okay, that's fine. And then over here on workloads, I'm going to create a new workload. I'm over here going to call this node application. And over here, we're going to specify the image that we want to utilize. And then here we are going to give our app a name, which is going to be called Node App. Looking good. So over here with serve traffic, we need to change this to port 3000 because that is what our application is running on, port 3000. And then when we create it, it's going to ask us if we want to allow all inbound requests, which means that anybody on the internet can make a request to our server and get a response back. In this case, yes, we do. And we're going to go ahead and create it. So now all we have to do is just go to our workloads. Let's go back to the workloads. Let me zoom out of here to find the workloads. Yes, right here. And as you can see here, it's not ready. It's still going. And right now, 0 out of the 6 locations are ready. So what you want is you can actually go over here to deployments. And for me, you can see a lot of errors because I already, I've done this multiple times. But over time, it's going to go ahead and try to run this. You can see, well, at this point, it's not ready. It's not ready. None of these locations are ready yet. So rather, sorry, my bad. These are not errors. These are just statuses for each particular location. So over here, you can see the status for this AWS location is not ready. This one over here, oh, it just got ready. So now our application is deployed here. Our application is deployed here. And we can actually start using our application even though it's not deployed everywhere. So if I go over here to my Node app, I can actually click on this URL and you can see I get my goodbye world. And let's just try this on Postman. So let's go over to Postman. And we're able to now, if I were to let's just increment this over here, zoom in a little bit. So if I were to make this request on Postman, and it should be a GET request, you can see I get my response back. So look how easy that was to deploy an application like this. Now that our application is deployed, what I'm going to do is just go ahead and stop everything so we don't spend any more money. As you can see, all of our applications are up and running on these AWS, Azure, Google Cloud platforms. So what I'm going to do is I want to remove that. So I'm just going to go ahead and stop it. And that's going to stop all of the workloads. And then over here, what we can do is go to delete this workload, press delete. And if I were to delete it, you can see now it's all gone. If I decide to go back to the website, well, it's still running, but after some period of time, it should stop.